Okay, first type cd and then go to browser and search for GitHub Kunalji123 and then go to the first link. And if you go to repositories, you'll find Sky 130 Circuit Design Workshop. Now click on this and then if you go to code, copy this link and here type git space clone and paste that link. So to paste it, just click on middle mouse button and enter. Now if you type cd and sky and press tab and designs, tab enter, and if you type ls, you'll find the list of the spice files that we're going to do in our entire workshop. And now let's go to this directory, type cd and sky 130 pr. If you type ls, you'll find cells, models and the tech file, tech directory. Now if we go to cells, type ls. Here you'll find NFET and PFET. In this entire workshop, we are going to use only these two cells. Now we go to NFET. Now type ls. You'll find spice files at different corners like typical, slow, fast, fast, slow. Now if we go to this typical corner, to open this file, type less and select this file and click middle mouse button. Now if we go here, you'll find the model parameters, different model parameters required for this NFET cell, and it contains this it contains all the model parameters for the cell for typical corner. Now if we go back, if we type less and if we go to corner spice for typical corner, you can see there are like different W and L values, like here W equal to 1.26 micron and L equal to 0.15 micron, and here if you can see W equal to 1.68 and 0.15 micron for L. So these are the different W and L values for this NFET 01V8. So in Sky 130 technology, they have been pre-categorized few W and L values for this NFET cell. So we have to, in our designs, we have to select W and L values within these scale sets only. If we take any values outside these scale sets, it won't simulate. So now if we go back, now let's go to models. Now type ls. And here you can see sky130.lib.spice. This is the library file that we are going to use in our all designs. So now let's open this. Type less sky130.spice. Now here you can see we are including all the spice files that contains in the cells directory inside that NFET and inside that the NFET TT corner spice, which we've seen earlier. So similarly for PFET, we are including spice file, and this is for TT corner. So this library file consists all the model files, all the library files that are required for designs for in our workshop for both NFET and PFET. So it contains for different corners. This is for TT corner and this is for SF, similarly for FF and likewise. So now if we go to all that spice, here we are including all that spice. In the all that spice, if we go back and here, let's open this all that spice. Now actually earlier in the files there's nowhere mentioned the units of W and L, so here it is mentioned. So the dot with the dot option, scale equal to 1 micron. So that means we are using for for all the values like with 1 micron. So W and L are in microns. Now we go back. Now let's clear this. And now let's go to the spice file. Now type ls. So now let's go to the spice file. For that, type vim and day1 file. Now here you can see we are including the library file which is present sky130.lib.spice, which is present in the sky130 directory inside that models inside that this file. And we are doing this in typical corner case. Suppose if we want to do it in slow fast corner, then you have to change it to slow fast. Instead of tt, just type sf. Similarly, if we want to do for fast corner, here instead of tt you have to type ff. So, and here we are including the enfet. This is for enfet, and we are including the W value of 5 microns and L length to be 2 microns. And this is the drain, gate, source and bulk. So drain we are giving it VDD, and source and bulk we are giving connected to ground. So since this is sub circuit, we are using X and the name. And if we go down, since we are doing this for ID versus VDS, so we are sweeping the VDS value from 0 to 1.8 volts with a step of 0.1, and we are giving the supply of 1.8 volts. And we are also sweeping the VGS value from 0 to 1.8 with step of 0.2. Now let's run this file and observe. For that, to run this file, type ngspice and day1 file name. Now here type plot minus VDD branch. Here you can observe this is the ID versus VDS curve for different values of VGS. So y-axis is ID, it is in microamps, drain current, and x-axis is VDS, it's in volts. We are sweeping from 0 to 1.8 volts, and VGS also we are sweeping with the step of 0.2 volts. So here you can see this is in cutoff region. Here if you can observe, this is in cutoff region, this one. And VGS, if we consider, this is the plot for VGS equal to 1.8, and this is for 1.6, and this is for 1.4, this is 1.2, and this is 1.1 volt, and this is 0.8 volts. And here if we zoom in this area, let's zoom this area. For that, select this area by clicking the right mouse button and holding it. And here you can observe this is the x-axis, and there is a small current in the current here for VGS equal to 0.6 volts. So here you can see it's around 2 microns. So there's a small current. This is in cutoff region for VGS equal to 0.6 volts. So if you can see, and we are sweeping with step of 0.2, and there is still for VGS equal to 0.4 and VGS equal to 0.2, we are not observing any curve. That is because we know that for device to be on, for NMOS transistor to be on, we need a VGS value to be at least threshold voltage. So for this transistor, the threshold voltage is somewhere around 0.55. So that's why before below the point below threshold voltage, we are not the device is off, so we are not observing any plot for vgs equal to 0.4 and 0.2. And you can see for 0.6 itself, it is in cutoff region, there's a small current, and from 0.8 we can observe the plots. Now if we want to now we want to observe id current at different points. Now let's consider vgs equal to 1.6. So this is a curve. Now if we want to let's consider vds equal to 1.3. Now if we want to observe current at this point, just click on this, uh, just click on this, and here you can see for 1.29 1.3 volts, the current is somewhere around 280 microns. And this is how we plot the id current, drain current, for at particular vds point, vds value and vgs value. And now you can continue with day 1 mcqs.